In this video, I will show you how an LLC converter works, and I will go through the voltages in all of the different parts of the converter. So we first start out with the VDC, which is the input voltage, and we say that it is 400 volts, and the output voltage is 50 volts. So we want to go from 400 to 50 volts, and both of them are DC. First, we want to look at the half bridge. So it goes from VDC to V1. Both of the MOSFETs can't be on at the same time. So when MOSFET 2 is on, the voltage would be 0, as you see here. And when the MOSFET 1 is on, the voltage would be equal to VDC, as you see here. Then we go up and down from 400 to 0. Now we're going to look at the resonant tank. So it goes from V1 to VP. The resonant tank is quite complicated and it varies with frequency. But at resonance frequency, the current I1 is equal to a sinusoidal waveform. The voltage over the capacitor is on average minus 200, which means that VP is equal to V1 minus 200. And that is what we get here. This probably doesn't make sense, but describing this in detail would be a video in itself. Now the transformer is a lot easier. It goes from VP to VS, and it only scales the voltage. The turn ratio is equal to 4, which means that we divide VP with 4. So we get 50 at the top and minus 50 at the bottom, which is exactly 1/4 of this one. The last part that we have is the rectifier. It only converts from AC to DC. So this VS is AC voltage. And then the rectifier just takes the absolute value of this voltage. And then we have the output voltage. So this is the LLC again. So you can see that this part divides the voltage by 2. This one at resonance frequency only multiplies with 1. And this part divides the voltage by 4. And the rectifier does nothing as well. So in total, that leaves us with 1/8, which is 50 divided by 400.